Once you've mastered solving linear equations, it's important to move into solving linear inequalities. The process is very much the same with a few minor differences. Let's start with an example such as 5y minus 7 is less than negative 4.2 plus 3y. Just like with linear equations, we need to get all of our variables together. I'm going to move my 3y to this side by subtracting, which leaves me with 2y minus 7 is less than negative 4.2. Now to continue to isolate the y's, I'm going to add 7 to both sides, which leaves me with 2y is less than 2.8, and then dividing both sides by 2, I get y is less than 1.4. Don't forget, in order to put that into interval notation, it's often easiest to move first to a number line. So if I estimate 1.4 to be about here, it's going to be an open dot because there's no equal to part included, and y is less than 1.4. I can then translate that into intervals, which you can review in that video if necessary. But remember, we're going to go from negative infinity up to positive 1.4, and we'll use a parenthesis, not a bracket, because the bracket would have been used had it included the number 1.4. As you can see, this is very similar to what we would do if we were solving a linear equation. The big difference comes in when you multiply or divide by a negative number. If you multiply or divide by a negative number, and that by is very important, you must flip the inequality. As an example, let's consider a compound inequality where we have an or statement. For example, negative 3 times x minus 3 is less than or equal to 27, or 9 plus x is less than or equal to 19. If this had been an and statement where there was an inequality in between, we would work from the middle to both sides. Here we treat it as two separate equations. The first thing I'm going to do is I'm going to distribute my negative 3, and I get negative 3x plus 9 is less than or equal to 27. Proceeding like I would with a linear equation, I subtract 9 from both sides, leaving me with negative 3x is less than or equal to 18. And here's the part where I am dividing by a negative 3. That tells me that this inequality is going to flip, and this becomes x is greater than or equal to negative 6. Working on the other piece of the compound inequality, I'm going to subtract 9 from both sides, and I get x is less than or equal to 10. Notice I did not multiply or divide by a negative, so that is going to remain the same. When I put both of these on a number line, I go out to positive 10. It's a solid dot because it includes 10, and it's less than or equal to 10. And in the blue, I'm out at negative 6, and it's greater than or equal to negative 6. Notice that as an interval notation, this goes all the way from negative infinity to positive infinity.